So today we're going to start graphing, so we're going to graph some more. We graphed some simple ones yesterday. And the Delta Math assignment today does have graphing in it, but we're going to do some things that may not pop up in Delta Math, but you're also going to have to graph some of these on Cami or paper or whatever you choose to do as well. So, but not today. That'll be another assignment. So the first thing we always do is factor. So we're going to factor. And I get x, and then this would be a -3 and a +1. And then I get x, and this would be a +1 and a +2. So after I factor, I decide, do I have a whole? In this one, do I? Yes. And I told you yesterday, not all of them do, and they don't, and we just happen to start with one that does again. So this is a -1 for my x value. When I simplify this, I get x -3 over x + 2. Okay, so this is the reduced function that I'm actually going to work with now. To find the y value, I'm going to find f of -1, which is going to give me -4 over 1. So it's going to be at -1, -4. Okay. So the next thing I look for are my roots. I get those from the numerator. So I do have roots, and they are at, or I have a root, and it's at 3. Vertical asymptotes come from the denominator, so I get x equals -2. Tangency and togetherness we haven't run into yet, but we will today. But here I have no exponents at all, so there's no possibility for that, so that's a none. Horizontal asymptotes, they are tied in degree, so do I have one? Yes, I do. So it is y equals, and my leading coefficients give me a ratio of 1. Remember, if I have a horizontal asymptote, no way I can have a slant asymptote. Y-intercept, I find f of 0, so it's going to give me -3 over 2. So we get 0, -3/2. Right here, I'm going to rewrite my reduced function so I can see it after I scroll. Any questions at this point? All right. So now I'm going to scroll, and let's do our sign chart. On the sign chart, I put my zeros and my asymptotes, so I will have a -2 and a +3 here. The -2 is an open circle because it's an asymptote. The +3 is closed. So then I look. If I substitute in a -3, that'll give me negative over negative, which is positive overall. If I substitute in 0, I'll get negative over positive. It's negative overall. And then 4 gives me positive over positive, which is positive overall. This is positive, negative, positive. Right, there's my sign chart. So now I'm going to graph everything we figured out. So instead of me scrolling up and down, I'm going to use my paper to get this. So we have a whole at -1, -4. There's the whole. I have a root at 3. I have a vertical asymptote at x equals -2. Horizontal asymptote at y equals 1. A y-intercept at 0, -3/2. Okay, so based just on the stuff from Rady, I feel pretty good about this part of the graph. Like, I'm pretty confident without even looking at sign charts and stuff that it's going to have to look like this, right? But what I don't know is whether or not I cross this asymptote since it's not on the axis. So I'm going to have to look into that. As far as the other part of the graph, well, I know it's not going to be up here because then it wouldn't be a function. I know it's not going to be down here because I don't have any togetherness. So I know it has to be in this part, and it would have to look like this kind of curve, but what I don't know is if it comes in really close or if it swings out really far. I also don't know if I cross the asymptote. So those are some things I have to figure out before I can go any farther. So I first want to get at least 1 point. Sometimes we have to get more than one to plot on here to get our curve in there. So let's just start. I usually like to start just one on the other side of the asymptote, because if it's right here, then we're golden. We can just, put that in there. So we're going to do a little t-chart. We'll do -3 for x. I'm going to substitute it in here, so that'll give me -6 over -1. So that gives me 6. So if I go to -3, and then 1, 2, 3, 4, 5, 6. Well, that's something, but still, it could come down like this, or it could swing out really far like this, and I really don't know what's happening there. So let's jump out a little farther, and let's go with maybe -5. So -5 would give me -8 over -3, so that's 8/3. So that's 2 2/3. I can estimate that pretty well. So we go to -5, and then 1, 2 2/3, about right there. So that gives me a pretty good idea of how that's going to swing, but I still don't know if it crosses the asymptote, so I don't want to draw it in yet. Here's how I'm going to figure this out. It's basically, I know that the asymptote is at y equals 1. And I know that this function is y equals this, but with a hole in it. So if I know both of those things are equal to y, I basically want to know, when does this function equal 1, or even does it, right? So if I take my function and I set it equal to 1, I can see what x value might give me 1. Or maybe it will tell me that it doesn't ever give me 1, and then I know it doesn't cross it. So I'm going to take my reduced function, x minus 3 over x plus 2, and I'm going to set it equal to 1, because I want to know what x value is going to give me a y value of 1. So then I'm going to multiply both sides by this x plus 2, so I get x minus 3 equals x plus 2. So then when I start to solve, when I subtract x from both sides, I end up with -3 equals 2. Is that ever going to happen? No. -3 can never equal 2, so I get this weird answer that makes no sense, which means I'm never going to get a y value of 1. Okay? So since I never get a y value of 1, that tells me I am not crossing that asymptote. Yesterday I just told you, because I didn't want to go into that just yet. But so now I know that I can do this. I am not crossing that asymptote. And I can draw this in. And I'm not crossing the horizontal asymptote. What questions do you have? Anything? And in this case, I really didn't even use my sign chart. I kind of used some logic, but the sign chart could have helped me some too. But nothing that you find in Rady or with the sign chart tells you for sure about crossing the asymptotes sometimes. If it's on an axis, yes, but otherwise we don't really know. Okay? Any questions at all? All right, let's look at number 2. All right, so the first thing we're going to do is factor. F of x equals, so I'll have -6 in the numerator. Denominator, this will give me x and x, so I'll have a -3 and a +2. And do I have any holes in this function? No, so we finally got one that's a none, right? Do I have any roots? No. If I don't have any x's in the numerator, there's no roots either, so it's just the empty set. Means I'm not going to cross the x-axis. So vertical asymptotes, I've got 2 of them, right? So I've got x equals -2 and x equals 3, and they are lines, so they always have to be written as lines. Tangency and togetherness, we still haven't run into that, but I don't have any exponents anywhere, so the answer to that has to be none. To get my end behavior, this is bottom heavy, so since it's bottom heavy, do I have a horizontal asymptote? Yes. Because remember, if we always say them in the same order, they're top heavy, bottom heavy, tied in degree. Top heavy would mean none, and it could be a slant asymptote. Bottom heavy means it's y equals 0. And if I have a horizontal, no way I can have a slant. Then to find the y-intercept, I'm going to find f of 0. It's going to give me -6 over -3 times 2. So that's going to be 0, 1. And then I'm going to rewrite. Any questions at this point? Okay, so let me scroll. I have two things that are going to have to go on my number line, a -2 and a 3. And they're both open circles because they're both asymptotes, right? And then the numerator is negative no matter what. So that -6 gives me a negative. Then if I substitute in a -3 down here, I'm going to get negative, negative. So that's negative overall. Between -2 and 3, I can pick 0. So the numerator is negative no matter what. Then I get negative, positive. So this is positive overall. 4, numerator is negative. And then I get positive, positive. Makes that negative overall. So this is negative, positive, negative. So if we think about what's happening here, look at my asymptotes, right? So if it's negative the whole time over here, we've seen that a few times, and I'm pretty confident it's going to have to look something like that, right? And this is going to have to look something like that. Well, then here, it's going to have to be positive the whole time. It's going to have some sort of parabolic shape to it, right? So let's plot our points and see what we can come up with, or plot everything we know and see what we can come up with here. So I have no holes, no zeros. I have a vertical asymptote at x equals -2 and one at x equals 3. Now I don't have any tangency or togetherness. I have a horizontal asymptote at 0, and I have a y-intercept of 0, 1. All right, just trying to figure out why this moved a little bit. 0, 1. So again, from my sign chart, since it's negative the whole time, the shape is going to have to come in like this. And I know without checking anything that I am not crossing this asymptote, because then I would also have to cross the axis, and it doesn't become positive. So when it's on an axis, it's a little easier to figure it out. So it's going to have to come in like this, but I'm going to have to find a point. This is going to have to be positive the whole time. And since I know this is coming down here, and I don't have any togetherness, then it can't be down here, plus it can't be negative. So this is going to have to come down and hit that point and go back up. And then, because it stays positive the whole time, and then this is negative the whole time, so it's going to have to go like this. So I feel like this one point in here is probably good enough to get this shape in, so I can sketch that in. Got that part. But I'm going to need some other points to get this down here. So my little t-chart, I'll go with -3. Let's see what happens with -3. Lost my function a little bit. All right, so if I substitute that in here, I'm going to get -6 over -6 times -1. So that's going to give me -1. I'll go to -3, -1. That's close enough into that corner that I feel like that 1 point's good enough, so I can sketch that in. Over here, I'm going to go with +4. So a +4 would give me a -6 over 1 times 6. So again, I get a -1. So I'm going to go to 4, -1. And then it looks like, ooh, but not that, because I went to my asymptote. Like this. Something like that. Okay. And again, you started off, I highly doubt you knew it was going to look like that. But based on what we found and what the signs have to be, there's only so much that can happen, and it just leads you right to it. What questions do we have? It's kind of like another puzzle, right? Let's look at number 3. So I'm going to start off by factoring. F of x equals, get x minus 3, x plus 2. Here I'm going to have x and x, both positive. Two numbers that multiply to give me 16 and add to give me 8, be 4 and 4. I do not have any holes, but I'm also not finished with that function there, because that denominator actually is a perfect square trinomial, which I'm assuming most of you don't just look at that and go, oh, it's a perfect square trinomial, and know what it is. There is a shortcut, it is a trick, but most of the time our minds aren't going that way. So I need to rewrite this. These two are the same, so it needs to be written as f of x equals x minus 3 times x plus 2 over x plus 4 squared. This is the function I'm going to work with. Okay, so we already decided there was nothing to cancel out, so no holes. This is none. I do have 2 roots here that I'm getting from the numerator, -2 and 3. Vertical asymptotes, I have 1. It is x equals -4. Okay, so this tangency and togetherness that we haven't come across yet. I have a factor, this x plus 4, that has an even exponent on it. If it was in the numerator, that's the tangency, that's my bounce. If it's in the denominator, it's my togetherness. So I have togetherness at x equals -4. And that's an asymptote because that's what your togetherness means. You're either both going to infinity or both going to negative infinity. It's the same. In behavior, they are tied in degree. And you can look back at your original function if you want to, and you can see your ratio of your leading coefficients is 1. So this is none here. Then I need f of 0. Again, you don't have to actually substitute it in. I mean, sometimes it's just kind of easier, but if I think about substituting it in, these x's all 0 out there, and I'm left with -6 over 16, which is -3/8. So 0, -3/8. Then I'm going to rewrite this. F of x equals x minus 3 times x plus 2 all over x plus 4 squared. Any questions at this point? All good? Okay, so let's scroll and take care of our sign chart. My crooked fraction. So I have 3 things going on here. Got this -4, got a -2, and a +3. So the -4 is open. The 2 and the 3 are closed. If I substitute in a -5, in the numerator I'm going to get negative. No matter what I substitute in the denominator, because it's squared, it's going to end up positive. So this is positive overall. If I substitute in a -3, I'm going to get negative. Denominator is always positive, so it's positive overall. So that makes that. Looks like I have an extra negative in there, which I do not. So let me fix that so nobody's confused when they're writing it down. Okay. Then between -2 and 3, it's 0. So that's going to give me positive, and then the denominator is positive, so it's negative overall. 4 will give me positive. So that's positive overall. So this is the first one since we've been graphing where our sign chart didn't just alternate the whole time. So let's think about why that is. This is an asymptote, and since these are both positive, it has to go like this. Well, that's what our togetherness is. Okay, that's what's telling us we have togetherness. We'll worry about the rest when we get over there. All right, so let's plot what we can, what we know at this point. I've got no holes. I have zeros at -2 and at 3. I have a vertical asymptote. X equals -4. I also have togetherness there. We'll come back to that. I have a horizontal asymptote at y equals 1. And I have a y-intercept at 0, -3/8. So that's like a little less than a half. So 0 and a little less than a half. It's right about there. Okay. So, since I am positive from -infinity to -4, I know it's going to be up here, but I don't know whether or not I cross this asymptote. And then from -4 to -2, I'm positive. Okay, so from -4 to -2, and I have this togetherness, clearly I'm going to have to cross that asymptote, right? So I know I'm crossing it at least once, and then it's negative, and then it's positive again. But what I don't know is if I stay underneath this asymptote, or if I go back above it and then come back down. So I have to figure out whether or not, or how many times I'm crossing this. Before I do that, I would also like some points over here to know what the heck is going on. So let me find those. I'm going to have x, y. So I will choose, let's see, this is at -4, so we'll choose -5. If I substitute -5 into there, I'm going to get -8 times a -3 over 1. So that's a positive 24. That's way off my graph. That helps me none. So I can move on to 6, -6. Let's see what happens there. So at -6, I would get -9 times -4 over 4. So these become positive. That cancels out. I get 9. I can graph that one. So I can go to -6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's good. It's there, but that's still kind of doesn't really tell me if I swing way far out here or if it's going to come down and swing like that. So let's just go ahead and skip over 7 because I'm not making very much progress. So let me try -8. If I substitute in -8, I will get -11 times a -6 over positive 16. So these can't, or those become positive. I can reduce this to 3 and 8. So that'll give me 33 over 8, which isn't a pretty number, but I think I could estimate that on my graph. 8 goes into 33 4 times with 1 left over, so it's 4 and an 8. So I'm going to go to -8, and then I'm going to go to 1, 2, 3, 4 in a little bit, and I'm right there. Okay, so I feel pretty good about the swing of my curve, but I still don't know if I'm crossing this asymptote. So the asymptote is at 1. So I'm going to take my reduced function, which isn't really reduced, but it's factored. I don't really want the factored form of it, though, because I'd have to multiply it all back together to figure this out. So if I use my original one, since I didn't cancel anything out, my original one was x squared minus x minus 6 over x squared plus 8x plus 16. And I'm going to set that equal to 1 because 1 is the asymptote. Not because 1 is always the magic number, but it's whatever the asymptote is. I want to know what values of x will give me a y value of 1, and that will tell me where all I cross my asymptote. So I'm going to multiply both sides by that denominator. So I'll get x squared minus x minus 6 equals x squared plus 8x plus 16. So I subtract x squared from both sides and they zero out. I'm going to add x over here, so this is going to give me 9x. I'm going to subtract the 16 over here, so that'll give me a -22. So I get that x equals -22 over 9. -22 over 9. So that's when my y equals 1. And so it only crosses one time. Since it only crosses one time, it has to be the time it goes right here, right? So if I plot this point, negative 22 over 9, so that's going to be negative 2 and 4/9, so it's about negative 2.5. So about negative 2 and about a half, that's when it's 1. That's where it's crossing that asymptote. Since that is the only answer I got, I know that when I come down here, it's going to have to stay underneath the whole time. And I know that this one is going to have to stay on top of it. So when I sketch this in, it's going to look like this. I'm not crossing the asymptote. Then remember, I have my togetherness. That's what this is telling me. So I have to start up here. I'm going to come down. I am going to cross the asymptote. I go negative until I'm there, and then I get back here, and then I'm positive, and I stay underneath. So it'll look something like this. What questions do you have? Anything? Okay, so if you were thinking all along, oh, well, they always look like they're always symmetric. Yeah, totally not, right? And when you started this, you had no clue what it was going to look like. And that's going to happen with these. You're not going to know. Some strange things are going to happen. But do you see how based on the information we have, there's only one thing we could possibly draw? You just try and match up that stuff and go, well, this is what has to happen. This is where it's going to have to go, and so forth. Any questions at all? All right, well, let's look at the last one. So again, start off factoring. F of x equals, in the numerator, I'm going to get x and x. It's going to have to be a negative 1 and a negative 3. And then I have x minus 2 down here. So I can't simplify anything. Like, this is it. This is the reduced function, or not the reduced, but the well, it's reduced as much as it can, but that's the function I'm going to use. So I have no holes, right? How many roots do I have? 2. 1 and 3. How many asymptotes do I have? Vertical. 1. One vertical asymptote, and that's going to be x equals 2. Do I have any tangency or togetherness? No, because there's no exponents anywhere, so this is a none. Will I have a horizontal asymptote? No, because it is top heavy, so this is none. So then that opens the door for a slant asymptote. The numerator is 1 degree higher than the denominator, so I can divide this. I don't want to divide this version of the function, but that helps me. I need that version, but this is the version I actually want to divide. Can I use synthetic division? Yes, that's awesome. So I'm going to put my 2 out here, and then I'll have 1, negative 4, 3. Bring my 1 down, so that's 2, negative 2, negative 4, negative 1. So my slant asymptote is y equals x minus 2. What do I do with this negative 1? Nothing, right? I ignore it. It tells me something, but nothing that I'm interested in knowing right now. So then my y-intercept, I need f of 0. So again, I can just kind of drop all those x's, and I get negative 3 halves, 0, negative 3 halves. And then I'm going to rewrite my function. This is x minus 1 times x minus 3 over x minus 2. What questions do we have? Anything? All right, so let's do our sign chart. I have 3 things on there. I have 1, 2, and 3, basically. 1 and 3 are closed. 2 is open. Substitute in a 0. It's going to give me negative, negative, negative. That's negative overall. So 1.5, that'll give me positive, negative, negative. That's positive overall. 2.5 will give me positive, negative, positive. That's negative overall. If I substitute in 4, that'll give me positive, positive, positive. It's positive overall. So this one alternates again. So why do you think all the ones that have been alternating are alternating and the last one we did wasn't? Because there was togetherness. Would it alternate the whole time if I had tangency? Think about that. If I had tangency, that means I have a bounce. So it would have to be positive, positive, or negative, negative, right? So here's the thing with the sign charts. We're going to stop writing them out we're going to make them, but we're not going to have to think through every piece. If there is no tangency or togetherness, you can find the first one, and then they alternate. That'll work every time, okay? So they don't always alternate, but if there's no tangency or togetherness, we can just figure out this first one, and then we can just alternate, and then that'll still help us with our graph, okay? Okay, so let's plot everything we can here. We've got roots at 1 and 3. We've got a vertical asymptote at x equals 2. We have no tangents here together, so we have a slant asymptote at x, or y equals x minus 2. Okay, so what's the slope of this line? 1, which means you're just going to go diagonally through these little squares. My y-intercept I know is at a negative 2, so I'm going to go to negative 2, and then I'm going to sketch in my asymptote, like so. Because I don't know about on Cami, but on here I can't use the line tool to make it dotted, and I'd rather not have like a real line on there. And then I have a y-intercept of 0, negative 3/2, so it's right there. Okay. So let's think about what we have. From negative infinity to 1, it's negative, which means my function is going to be coming up like this. Here's my asymptote. Negative infinity to 1, it's negative. And then from 1 to 2, it's positive, so it's going to keep going like this. Then from 2 to 3, it's negative, so it's coming up like this because I didn't have any togetherness. And then 3 to infinity, it's positive. What this doesn't tell me is whether or not I cross my slant asymptote, because I can cross that one too. Let's see, do I feel like I have enough points plotted? I know it's going to look something like this and something like this, so I feel like my points are good. I just need to figure out if I actually cross the asymptote, all right? So I'm going to take I will take the original function because I want it multiplied together, that x squared minus 4x plus 3 over x minus 2. I'm not going to set it equal to 1 like I have the other times. I used 1 because 1 was the asymptote I wanted to know if we were crossing. This time I want to know if we cross this slant asymptote, and the slant asymptote is y equals x minus 2. So instead of this equaling y, it's going to equal x minus 2. So now I'm going to multiply both sides by this denominator, and I will get x squared minus 4x plus 3 equals, and this is going to be x plus 2, not x plus 2 because there's no magic there, sorry, x minus 2 squared. So I need to square this. So x squared minus 4x plus 3 equals, this is not x squared plus 4, right? This becomes a trinomial. This is x squared minus 4x plus 4. So now that I've got that multiplied out, I'll just start solving it. I can subtract x squared from both sides, they zero out. I can add 4x to both sides, they zero out. So that leaves me with 3 equals 4. Does that make any sense? Nope. And since it doesn't make any sense, I do not cross the slant asymptotes. Okay. So I'm just going to come down here, sketch this in like this, and then sketch this part in. Whew. So I don't want to curve back. I need to hit my point. I love the undo button. There we go. And that is what your function looks like. Okay. Any questions at all? All right. So The ones you're going to have to graph on Delta Math today, they're going to be, I don't think there's any that have slant asymptotes in there. So they might be even a little bit simpler than this. But if you can do this, you can do those for sure. But we're going to graph some by hand that have some of these weird little things in them for sure. We're going to continue graphing some more together tomorrow and the next day so that you can get the hang of different things. Okay? Any questions at all? Awesome.